looked at. I don't think that we're able to see the entire eye in one field of view, so that's why I kind of like this picture. But you're able to see we've got this sagittal section through the eye. We're able to see all the structures of the eye, most of the macroscopic structures of the eye. Here's the lens. This pigmented structure that is most anterior is the iris. Okay? This hole then in the center would be what? That's the pupil, absolutely. And if we move a little bit more posterior, we see slightly pigmented structures here, but doesn't look anything like the iris. This is the ciliary body. The ciliary body is made up of smooth muscle, and smooth muscle is attached to suspensory ligaments. Those suspensory ligaments are attached to the lens of the eye. You can't see them, but they'd be attached right here. And those ciliary muscles, when they contract, they put pressure, or they put tension on those suspensory ligaments. The suspensory ligaments then can change the shape of the lens, allowing us to focus light on different parts of the retina. Robert?
It doesn't actually change the shape of the lens, it changes the direction of the lens it's facing, maybe?
No, it changes the shape slightly.
It does change the shape.
Yeah. Did you read something else?
No.
Or you were just thinking that?
I was just thinking actual lens is really hard.
It is very hard, and I think part of that is because it's preserved in what we've looked at, but it is just in general, it's really hard. But it does microscopically change the curve of that lens, which then forces that light to be focused or bent in different directions or at different angles as that light comes in. And then that light comes in, shines on the back of the retina, or makes its way back to the retina, which is this innermost layer right here. That's where we're going to find the photoreceptors, those rods and cones. Those rods and cones are going to be stimulated by very specific wavelengths of light. And when they're stimulated, they generate an action potential. Okay? That action potential then travels down their axons. All the axons of the retina converge here at the back of the eye, at the blind spot, or the optic disc. And all of those axons then run back towards the brain, and that one optic nerve will cross over. So from the left eye, it crosses over via the optic chiasm to the right side of the brain, and vice versa for that right optic nerve. Crosses over and makes its way to the left side of the brain. Elsa?
Is the ciliary body the same as the ciliary muscle?
No, the body is made up of ciliary muscles. Okay, so like your body's made up of muscles, the ciliary body is made up of a bunch of ciliary muscles.
Okay,
And then what else? We're not able to pinpoint the choroid because we are so zoomed out, or what's the tunic? Not the choroid. The vascular tunic. Vascular tunic. We're not able to see it, but you definitely see sclera here around the outside, and they're showing this sclera on the outside up there too.